Hello friends, welcome to Bindu Dhadwal chemistry lessons. Our topic for today is colloidal state. Thomas Graham in 1861 observed that the solutes such as starch, glue and gelatin could not pass through the parchment membrane. So on the Greek word colla, he named such substances as colloids. Colla means glue. Whereas on the other hand, the substances like NaCl, urea, sugar could easily pass through the parchment membrane and they were called crystalloids. So colloidal state of matter is a state in which the size of particles is between 1 to 1000 nanometer and particles can pass through filter paper but not through vegetable or animal membrane. The solutions can be classified into three types depending upon the size of their particles: true solution, suspension and colloidal solution. A homogeneous solution which contains small solute particles dispersed through a solvent in which the particle size is less than 1 nanometer. Such solutions are called true solutions. The particles are invisible through ordinary or ultra microscope, and the particles can pass through ordinary filter paper and animal membrane. Suspension, on the other hand, is a heterogeneous mixture which contains small insoluble particles. Particle sizes greater than 1000 nanometer, for example dirt, and they are visible through microscope and cannot pass through animal or ordinary membrane. Colloidal solution is in between. It is a heterogeneous mixture which contains particles of intermediate size, for example milk. Particle size is between 1 nanometer to 1000 nanometer. The particles are visible through ultra microscope and can pass through ordinary filter paper but not through animal membrane. So in all, you can differentiate the particles of true colloidal and suspension through their size. If the size is less than 10 raised to the power minus 9 meters, then it will form a true solution. It is between 10 raised to the power minus 9 and minus 6. It will form a colloid, and it's greater than 10 raised to the power minus 6 meters. It form a suspension. In terms of angstrom, less than 10 angstrom true solution, between 10 to 10,000 angstrom colloidal, and greater than 10,000 angstrom suspension. In terms of picometer, less than 1000 picometer true solution, between 1000 and 10 raised to the power 6 picometer particle size colloidal solution, greater than 10 raised to the power 6 picometer will form a suspension. And in terms of nanometer, you already know, less than 1 nanometer true solution, between 1 and 1000 colloidal, and more than 1000 nanometer will form a suspension. Distinction between suspension, colloidal solution and true solution. Suspension is a heterogeneous mixture. Colloidal system is also heterogeneous. True solution is homogeneous. 1000 nanometer suspension, then between 1 nanometer to 1000 colloidal system, and less than 1 nanometer true solution. Then separation by ordinary filter paper is possible in suspension but not possible in colloidal solution or true solution. By ultrafiltration, separation is possible in suspension. It is possible in colloidal solution but not possible in true solution. Settling of particles. The particles of suspension settle under the force of gravity. The particles of colloidal solution will not settle. They will settle only on centrifugation, whereas true solution particles do not settle at all. Visibility. The particles of suspension are visible to naked eye or under a microscope. Colloidal solution, you can see the particles when they scatter light under ultramicroscope, whereas particles of true solution are invisible even under ultramicroscope. Appearance of suspension is opaque, it's generally transparent, it's always transparent. Tindle effect. Tindle effect is when the light is scattered into a bluish cone. Then the effect is called Tindle effect. Suspension show, colloidal solution show, but true solution does not show Tindle effect. Diffusion of particles. The particles do not diffuse in suspension. They diffuse slowly in colloidal solution. They diffuse rapidly in true solution. Brownian movement is shown by suspension, may be shown by suspension particles, is shown by colloidal particles, and is negligible in case of true solution. The Brownian movement is the zigzag path followed by particles of a colloidal solution, because when they strike each other they get dispersed in different direction. This movement was observed by Brown, so it's called Brownian movement. Phases of colloids and their classification. A colloidal solution consists of two phases: dispersed phase, which is in smaller proportion, and dispersion medium, the component which is present in excess. There are 8 types of colloidal systems depending upon the physical state of dispersed phase and dispersion medium. You can classify different types of colloids under various factors. First is physical state of dispersed phase and dispersion medium. When the dispersed phase is solid and dispersion medium is solid, this kind of colloidal solution is called solid sol. Example, alloys and colored glasses. This solid in liquid, it is called sol. Example, paints. Solid in gas is called aerosol. Example, smoke, dust, storm and haze. Solids in gas, liquids in solids is called gel. For example, jelly, butter, cheese, boot polish, curd. Then liquid in liquid is called emulsion. Example, milk, hair cream, emulsified oils and medicines. Liquid in gas, aerosol, mist, fog, cloud, insecticide, spray are some examples. Gas in solid sol, pumice, stone, foam, rubber, examples. Gas in liquid is called foam. For example, soap, lather, froth, whipped cream, soda water, all are colloidal solutions of gas in liquid. Now, based on the dispersion medium also we can name the colloids accordingly. For example, if dispersion medium is water, the sol is called hydrosol. If it's an alcohol, it's called alkosol. If dispersion medium is benzene, it's called benzosol. If it's air, it's called aerosol. Classification based on nature of interaction between dispersed phase and dispersion medium. That is, particles of dispersed phase have great affinity for dispersion medium, then it's called lyophilic colloid. And if there is no affinity between particles of dispersed phase and dispersion medium, it's called lyophobic colloid. Differences between lyophilic colloids and lyophobic colloids are: lyophilic colloids are easily formed by direct mixing, whereas these are formed only by special methods. Lyophilic colloids have particles which are true molecules and are of big size. The particles are aggregates of many molecules. The particles are not easily visible in lyophilic colloids. Particles are easily detected under ultramicroscope. Lyophilic colloids are very stable. Lyophobic colloids are unstable and require traces of stabilizers to stabilize them. Lyophilic colloids are not easily precipitated by small amounts of electrolytes. Large quantity of electrolytes may be needed to cause coagulation. Lyophobic colloids are easily precipitated by addition of small amounts of suitable electrolytes. The particles do not carry any charge in lyophilic colloids. They do not move in any direction in the influence of electric field. But if you see the particles of lyophobic colloids, the particles will move in a specific direction. If it's positively charged, it will move towards cathode. If it's negatively charged, towards anode, depending upon their charge. The lyophilic colloids are reversible in nature. Anytime you can mix solvent in the colloid and make it again in colloidal form, whereas lyophobic colloids are irreversible in nature. Once precipitated, cannot form colloidal soul by simple addition of dispersion medium. Particles are heavily hydrated in lyophilic colloids due to attraction for solvent. Particles are not appreciably hydrated due to hatred to dispersion medium. Viscosity of soul is much higher than that of dispersion medium in lyophilic colloids. Viscosity is nearly the same as that of dispersion medium. Surface tension is lower than that of dispersion medium. Surface tension is almost same as dispersion medium. The lyophilic colloids do not show Tindle effect, they show Tindle effect. So, based on the type of particles, these colloids can be multimolecular colloids, macromolecular collides, and associated collides. Multimolecular collides, when on dissolution, atoms or smaller molecules of substance having diameter less than 1 nanometer aggregate together to form particles of colloidal dimension. The particles thus formed are called multimolecular collides. छोटे मॉलिक्यूल्स है और वो एग्रीगेट करके एक पार्टिकल बनाते हैं जिसका साइज जो है कोलाइडल साइज हो जाता है, तो इस तरह के उसको मल्टीमॉलिक्यूलर कोलाइड्स कहते हैं. तो एग्जांपल्स आर सोल्स ऑफ गोल्ड एटम्स, सोल्स ऑफ सल्फर-8 molecules. Macromolecular collides are substances having big size molecules called macromolecules which on dissolution form solution in which the dispersed phase particles have size in the colloidal range. For example, starch, cellulose, protein, enzymes, and gelatin. We also have artificial macromolecular collides like nylon, polythene, plastic, polystyrene, etc. Associated collides are substances which, when dissolved in a medium, behave as normal electrolytes at low concentration but behave as colloidal particles at higher concentration due to the formation of aggregated particles. The aggregated particles thus formed are called micelles. So, under normal concentrations, they will be forming a true solution. But when concentration crosses a particular level, they will form this associated collide. The concentration above which micelles are formed is called critical micelle concentration. Similarly, the temperature above which the micelle formation takes place is called Kraft temperature and is represented by Tk. The associated collides basically contain both hydrophobic portion and hydrophilic portion. For example, in the sodium stearate molecule C17H35, this portion is hydrophobic in nature. It forms the tail of the molecule, and the COO negative Na positive portion forms the hydrophilic head of the molecule. And when they form an aggregate, it is in this manner. This aggregation of different molecules will form a micelle. So the hydrophobic portion is towards inner side and hydrophilic portion is towards the outer side. Difference between multimolecular, macromolecular and associated collides. The multimolecular collide consists of aggregates of atoms or molecules which have diameter less than 1 nanometer. Example, sols of gold and sulfur. Macromolecular collides consist of large size molecules, generally polymer, for example, rubber, nylon, starch and protein. Associated collides consist of aggregation of large number of ions which behave as colloidal size particles at higher concentration, for example, soap solution. The atoms or molecules of multimolecular collides are held by weak van der Waals forces Macromolecular collides are flexible, take any shape. The associated colloids behave as normal electrolytes at low concentration and colloids at high concentration. Their molecular masses are not very high, multimolecular. Their molecular masses are high. Macromolecular, the molecular masses are also high. They usually have lyophilic character. Macromolecular have lyophilic character, and the molecule of associated colloid has both lyophilic and lyophobic group present in it.